Hello children, welcome in maths class. Let us continue exercise 13.3. We are in question number 5. So, we will read the question. Question is here: a container shaped like a right circular cylinder having diameter 12 centimeter and height 15 centimeter. So, first solid we have here right circular cylinder. So, for cylinder we have diameter 12 centimeter and height of cylinder is 15 centimeter. We can write for cylindrical container. Okay, so for cylinder we need radius and height. Diameter is given, no matter, we can find radius. Radius will be diameter by 2, that is 6 centimeter. So, next part of question what says? This container is full of ice cream, then the ice cream is to be filled into cones of height 12 centimeter and diameter 6 centimeter, having a hemispherical shape on the top. So, we have this cylindrical container, it is full of ice cream. The first solid what it is mentioned in this question, cylindrical container, it is full of ice cream. Ice cream is full in this container, and then this ice cream is to be filled in cones, height of cone. So, another is for cone height and radius. Let us see what we have. Height is 12 and diameter 6. So, not radius, it is diameter. Height is 12 and diameter 6. Having a hemispherical shape on the top. So, this ice cream will be filled in conical shape. We can say, you may be seeing this kind of kulfi or ice cream. When we go for buying this kind of ice cream, the shape will be like this. So, this top will be hemispherical, and then for conical portion we have diameter and radius. Diameter is 6. So, radius will be surely 3. We can mention here radius will be 6 by 2, that is 3 centimeter. For conical portion, surely for hemisphere also the same radius, same diameter will be, and then we can mention here for hemisphere also the radius will be same, that is 3 centimeter. So, question is what asked here? This container is full of ice cream. This kind we can say biscuit, conical shape biscuit is there, ice cream will be full in that. So, when it is filled, this conical portion will full and then top will be hemispherical. So, how many this kind of cone with hemispherical top can be filled with this amount of ice cream? That is the question. So, what we will do? This all the ice cream is distributed among can say, or filled among some cones with hemispherical top. That means, volume of this ice cream will be equal to the volume of ice cream filled in number of cones with hemispherical top. We do not know how many going to be filled, but we will find the volume of ice cream in the container, cylindrical container. Then we will calculate the volume of ice cream in one cone with hemispherical top and divide. We will find the number of cones, how many can be filled. So, let us start that. We can do part by part. We first go for volume of ice cream in cylindrical container. Volume of ice cream in cylindrical container. Formula we know, that is pi r square h, pi 22 by 7, radius of cylindrical portion, this radius is 6 and height we know already what is given, that is 12. Cylindrical height is not 12, cylindrical height is 15. So, radius is 6 into 6 and height is 15. So, this is the amount of ice cream in the container, volume of ice cream in the container. You may be thinking we will cut and all those things and get the exact amount. No need, because later we are going to divide from the volume of cone with hemispherical top. So, we will not cut and get the exact value later, last part when we are going to divide we will do. Now, we are finding the volume of ice cream in one cone with hemispherical top, What question is saying? That way we are going to calculate it. There is container cylindrical, we found how much amount, what amount of ice cream is there in that. Now, conical shape with hemispherical top, let us see. So, what is this? Volume of ice cream in one cone with hemispherical top. That means, here we will find volume of cone plus volume of hemisphere, because two shapes it has, conical shape, hemispherical shape. Volume of cone 1 by 3 pi r square h plus volume of hemisphere 2 by 3 pi r cube. So, 1 by 3 pi 22 by 7, radius of conical portion, that is 3 into 3, height of conical portion how much it was? 12. We can show here also in diagram 12. So, 12 plus 2 by 3 pi 22 by 7 and radius of hemisphere also will be the same as radius of cone. So, 3 into 3 into 3. Here we need to simplify because there is plus in between. So, let us see 1 by 3, 2 by 3. So, we can take common 1 by 3. 22 by 7, 22 by 7, we can take common 22 by 7. 3, 3, 3, 3, we can take common 3 into 3. Then see carefully what is remaining, 1 by 3 is out, 22 by 7 out, 3, 3 out, 12 is remaining in first place, plus 2 by 3, we took common 1 by 3. So, 2 will remain into 22 by 7 is out, 3, 3 out, another 3 is remaining. Here we can cut 3, 3 ones are 22 into 3, 66 by 7 into 12 plus 3 2s are 6. We get 67 by 7 into 18. So, this much ice cream, amount of ice cream needed for one cone, and total amount of ice cream is here in container, that is 22 into 6 into 6 into 15 centimeter cube. So, finally, we can now find therefore, number of cones with hemispherical top which can be filled with the ice cream, which can be filled with ice cream. Is equal to total amount, that is 22 by 7 into 6 into 6 into 15 divide by, so by the amount of what is that, ice cream in one cone, we get 18. So, simple, it is 66 by 7, we could have brought 7 here instead of writing here. One step we can make our solution shorter. So, 7 7 gone, 6 1s are, 6 3s are, here 6 1s are, 6 11s are, 11 1s are, 11 2s are 22, 3 1s are, 3 5s are 15. We find 5 2s are 10. So, 10 cones with hemispherical top can be filled with the ice cream available in the container. I hope you have understood. The concept is what? How much ice cream is in the container? We are going to fill in number of cones. The shape of cone is not only cone, top of is hemisphere, and we calculate and both volumes separately, and then we divide and we find the number of cones. Now, let us go in another question number 6. Now, question is here, how many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimension 5.5 centimeter into 10 centimeter into 3.5 centimeter. So, understand this question, how interesting it is. We have coins, dimension of coin is there. So, for silver coin, what is the dimension? It is diameter 1.75 centimeter and thickness 2 millimeter. One diameter is in centimeter and thickness is 2 millimeter. Then how many coins of this size we will melt and we will make a cuboid? So, for cuboid dimension is 5.5, that is length 5.5 centimeter. Another one breadth, we just consider length, breadth, height or length, breadth, thickness, whatever, 10 centimeter and 3.5 centimeter breadth and height or thickness. So, surely coins are smaller, bigger object is cuboid. So, we will have to melt some numbers of coins so that we can make the diameter cuboid of this dimension. So, let us first find the shape of coin. Do you know what is the shape of a coin? It is not circle, do not say it is circle, it is circular, because it has thickness. So, it is cylinder. It has thickness, that is the height of coin, and from center, radius and all that things you know. So, coin is cylindrical. How many coins we will melt? The volume of cuboid, like last question, ice cream, amount of ice cream or volume of ice cream in the container divided by the volume of ice cream in the cone with hemispherical top. In last question I am reminding you. Here also volume of cuboid divided by volume of a coin. So, we can do all together or we can do part by part. So, let us start part by part. First coin. So, we will find volume of a coin, volume of a coin, one coin volume, then this cuboid volume, and then divide the volume of cuboid by volume of coin. We will get number of coins. Anyway, but problem is here. What is the problem? All the dimensions we are seeing in centimeter, but thickness of coin is in millimeter. We are not allowed to work with different units. Remember it, in whole surface area and volume and areas, wherever you are working, you need to work with same unit. If units are different, we need to convert it into same unit. So, all are centimeter, this millimeter also we will convert into centimeter. How? We all know millimeter, centimeter. It is for one step only. So, each step is of 10 unit. That means 2 millimeter is 2 by 10 centimeter. We can bring it in decimal form or we can continue with 2 by 10 also, no problem, but that is now centimeter. Let us go volume of coin. What is the shape of coin? Cylinder. So, cylinder formula pi r square h. Pi 22 by 7, radius not there, that is diameter. So, we will get radius. What will be radius? Half of diameter, 1.75 by 2, it is centimeter. So, continue with that, no need to simplify here and all. So, radius square mean 1.75 by 2 into 1.75 by 2. Then height is the thickness, that is 2 by 10. So, this is the volume of centimeter cube, is the volume of one coin. Again, we are not going to cut and simplify and find the exact volume of coin. We don't need what is the volume of coin. We need how many coins will be melted, number of coin we need to find out. And that we have understood, bigger object volume divided by the smaller object volume. So, we will go for volume of cuboid and volume of cuboid. Volume of cuboid we all know, length into breadth into height. That is very simple one, 5.5 into 10 into 3.5. So, this is the volume of cuboid. So, cuboid we are going to make, we are melting the coin. So, therefore, number of coins to be melted to make a cuboid. So, what is the concept here? The bigger object volume divided by smaller object volume. So, bigger object cuboid you are going to make 5.5 into 10 into 3.5 divided by volume of a coin. Look at here, these all are fractions. So, all numerator will remain here in denominator and all denominator will go up in numerator. When we are dividing, it will just turn, numerator will become denominator, denominator will be numerator. So, 22 by 22 will remain here, 7 will go up, 1.75 will remain here, 2 will go up in numerator. Same thing, 1.75 will come here, 2 will be in numerator. 2 by 10, 2 will remain here, 10 will go up. So many numbers are here, we should not get puzzled. Slowly we will cut and we will get the correct number of coins. We remove from decimal, decimal from denominator, it will go in numerator. What it will become? 100. Again this decimal we remove, one more 100 will be there. Let whatever come, just follow the process. This decimal from numerator we remove, in denominator 10 will come because one digit is there after right side decimal. Here also we remove decimal, 10 comes. Now everything is okay, let us start cutting the number. 0, 0, again this 0, that 100 is gone, this 10 gone. 2, 2 ones are 2. Again 22, 11 twos are 55, 11 fives are. Again these 2 ones are 2 ones are. So slowly numbers are reducing. Now 5, 175, we can cut, 5 ones are 5, 5 threes are 15, 2 came here, 5 fives are. This is also gone. Now you look at 35, 35, 35 ones are, 35 ones are. Now still 10, 175, 5 twos are 10, 17, 5 threes are, 2 came here, 25, 5 fives are, 35. 7 is here, 7 ones are, 7 fives are, 5, 10, 5 ones are, 5 twos are 10. So denominator now nothing remains, whatever is there in numerator, 1, 2, 1, 1, 1, 1, 2, 100. That means 2 into 2 into 100. Finally we get, we can write here, 2 twos are 4 into 100, 400 coins we will melt, and thus this dimension cuboid we will be able to make. I hope you have understood. In the last step so many numbers are coming, only that we should be little careful, don't miss any number and simplify, calculate properly and get the number of coins. See you in the next video.